Alright guys, in this video we're going to do some particle motion multiple choice questions and an FRQ question. So it says a particle moves along the x-axis and the velocity is given by that quadratic equation. And this only works for time greater than or equal to 0. If the particle is at position 2 when time is 0, what is the position of the particle at time 1? So there's a couple ways we can think about this. We could understand that if I take the derivative of position, I get velocity. If I take the derivative of velocity, I get acceleration. But if I do the antiderivative, I go back. So if I'm given velocity and I want to find position, I could find the antiderivative of 3t squared plus 6t. So antiderivative of that would be what? Reverse power rules would be t cubed plus, add 1 to the exponent, reciprocal of that is 1/2, 6 times 1/2 is 3. And then it would be a plus c. It's like I'm finding a general solution to that differential equation. You can think of it like that from Unit 7. And then if I want to find c, the specific solution, this would be equal to like position at a certain time. But it could be really anything. But if I have this initial condition, I could say, okay, if I plug in p of 0, that gives me 0 plus 0. This is weird, a little bit weird way to write it. P of 0 is 2. And if I plug in 0, 0 plus c would be c, so c is 2. So p of t is t cubed plus 3t squared plus 2. Then p of 1 will give you 1 plus 3 plus 2, which is 6. So that is, think about it like a differential equation way. Okay, I think the way we kind of want to learn it now is I know that given position, basically, the given position at a time, if I'm given velocity, is basically the fundamental theorem of calculus. If I have position when time is 0, I want to find position when time is 1, I could integrate the velocity, and it basically tells me the distance traveled, right? Or displacement. It would be 3t squared plus 6t dt. That's equal to, okay, that's what I was going to write. I was going to write like this in more general terms. So this would be equal to position at time 1 minus position at time 0, because position is the antiderivative velocity. So there's that fundamental theorem of calculus. If I actually plug in my numbers, the integral from 0 to 1 of 3t squared plus 6t dt, position when time is 1 is what we're trying to find, and position at time 0 is 2. Now if I go through and find the antiderivative of this, you give me t cubed plus 3t squared. You evaluate it from 0 to 1. That is equal to p of 1 minus 2. Plug in 1, I get 1 plus 3 is equal to, and then I plug in 0, it's gone, right? Is equal to p of 1 minus 2. Add 2 to both sides, and I see that same kind of the numbers that I got over here. So the answer is 6 again right here. P of 1 would give you 6. So 2 ways of thinking about the same question. Either way, perfectly right. All right, number 2, calculator is not allowed. A particle travels in a straight line with a constant acceleration of 3 meters per second. Okay, constant acceleration. So acceleration is the derivative of velocity. Just going to keep that in mind. 3 meters per second. If the velocity of the particle is 10 meters per second at time 2, how far does the particle travel during the time interval when its velocity increases from 4 meters per second, there's a B, a D there, to 10 meters per second? Okay, there's a lot there. So constant acceleration, A of t is equal to 3, so it's always 3. Okay, V of 2 is 10. So we got to think, this is a really cool question. The acceleration is the derivative of velocity, which means it tells you the rate of change. It tells you the slope. So velocity is increasing 3 meters per second every second. So if I know at time 2, velocity is 10, what is the velocity at 3? It would be 3 more, right? So it'd be 13. Okay, so I'm going the wrong way. I want to know when is the velocity 4. So I'm going to go backwards. So v of 1, so 1 second before v of 2, the velocity would be 3 less. And then v of 0, 1 before that, would be 3 less, so 4. All right, so at least I'm seeing some numbers now that, like, that last question, or the last part, the question part, it says, how far does the particle travel? So total distance. I have to know that total distance is the integral from time interval a to b, the absolute value of velocity. If I just want to know net change, I don't have absolute value, but total distance, how far does it travel? Like if it's going right, left, whatever. But this is always going right, but still. I think the absolute value bars are needed, even though they don't make a difference on this one. Okay, so what does it say? How far does the particle travel on the time interval when its velocity increases from 4 to 10? So the time interval is from 0, because that's when the velocity is 4, to 2, because that's when the velocity is 10. So I'm finding the antiderivative from 0 to 2 of velocity, really technically the absolute value of velocity, dt. All right, so what would this be? Find the antiderivative. Okay, so since we're just looking when t is positive, all these are going to be positive. It says the acceleration doesn't turn around and go left. It's just constant positive acceleration. So I'm going to lose the absolute values here. And just go 0 to 2 v of t dt. And no, actually plug that in. Velocity function, does it tell us? Oh, we got to come up with a velocity function, don't we? So what is the velocity function? So it's at velocity is 0, it's 4. So it's like your y equals mx plus b idea. It's a constant acceleration. So that's the way the velocity is changing, plus 4. So velocity is 3x plus 4 dx. Find the antiderivative of 3x, it'd be x squared times 1/2, so 3 over 2, plus 4x, evaluate from 0 to 2. Plug in 2, plug in 0, but the 0 won't matter. So plug in 2, 4, oh, right there, 2 is 4. 4 times 3 is 12 over 2, plus 8. So 6 plus 8, 14. So the answer would be B. So that was a pretty tricky question. A lot of steps to that one. All right, calculator not allowed again. If the position of a particle on the x-axis at time t is -5t squared, then the average velocity of the particle is, okay, this is a great question, average velocity. If I want to do, so, okay, this is actually weird. Okay, position is this. Okay, I thought this was going to be an average velocity, like 1 over 3 minus 0 from 0 to 3 of velocity. But the problem is we don't have the velocity. Ooh, we kind of do. Okay, I'm thinking about this a little bit different. If this is position, velocity would just be -10t, right? I wonder if this is going to give us the same thing if we do average rate of change. Okay, I'm doing this right now for the first time. This could go terribly wrong or could be good. So if I find the antiderivative of that, what would that be? So it's just 1 over 3 on front. Antiderivative of this would be t squared, 1/2, no -10, so it's -5. Evaluate that from 0 to 3. So this would be what, 1/3 of, okay, plug in 3, 3 squared is 9. 9 times -5 is -45. Divide that by 3, -15. Okay, I got -15 a different way. So the way I did it earlier was just AROC. If you're given position, average velocity would be, I wonder if one of these is not right though. Average rate of change, it's gotta be the same thing, so yeah, it's probably good. Average rate of change would be equal to, so average rate of change, average velocity is equal to the average rate of change of position at 3 minus position at 0 over 3 minus 0. Oh my goodness, that's cool. So this was position at 3 minus position at 0 divided by 3. Oh, that's cool. I didn't know that till just now. Yeah, okay. That's exciting, to me at least. Okay, so you plug in 3, what would that be? 3 squared is 9, so negative 45 minus 0 over 3 minus 0. Look at that. Same thing. That's cool. All right, next question. All right, calculator not allowed. The table below gives selected values of velocity, v of t, of a particle moving along the x-axis. At time 0, the particle is at the origin. Which of the following could be the graph of the position? So this is one of those connecting f prime, and f prime prime graphs. So if I'm given the derivative, this is f prime, I'm going to go backwards. So if these are all derivatives in the table, the graph, I'm going to look at it. If I look at time 0, it needs to have a negative slope. At time 1, it needs to have a slope of 2. At time 3, it needs to have slope 0. So at time 0, let's just look at A. At 0, is that slope negative 1? Well, it doesn't really like touch there. I don't know. Maybe I shouldn't use 0 because I don't have like a point on the other side. I'll use 1. At point 1, the slope needs to be 2. So those are both 2. At point 1, that could be 2. That could be 2. At point 1, this can't be. That's not 2. So E's out. We eliminated that one. At time 2, the derivative needs to be 3. That doesn't look like it. That could be. At time 2, that doesn't look like 3. Neither does that. So it looks like these are all wiped out. Let's just make sure C is good. At 3, that could be slope 0. So yep, I'm saying it's C. There we go. You might have another way of doing that one. If you do, share it in the comments maybe. Some other nerds might have fun. Listen to another way to do it. All right, what is this one? Okay, calculator active, still multiple choice, and then we'll do the free response. Okay, a particle moves along the x-axis so that at any time t greater than 0 or equal to 0, its velocity is given by that. Okay, good thing it's calculator active. That looks like a pain to mess with. What is the acceleration of the particle at time t equals 4? All right, so you could do this by hand. Well, for a second, you can find the derivative by hand. But since it's calculator active, in Desmos, define v, you can say v of t is equal to 3 plus 4.1 cosine of 0.9 t. Define that. And then in the next line, acceleration is just the derivative of velocity. But in Desmos, you can't say a of 4. It doesn't know what a is. So you have to kind of trick the calculator a little bit. Tell Desmos, I want v prime of 4, which is equal to a of 4. And when you plug this into your Desmos, you get 1.6329. So the answer would be C. Pretty easy question. I don't know if you got it really. If that was really hard for you, I'm sorry. To say that was easy didn't make you feel bad. Sorry. It was a very difficult question. All right, number 6. This is, what is this? Free response. Calculator is allowed. 2 runners A, runners B. I wish they would have given them names. Like, give me a name. Runner A sounds lame. So runner A and runner B, they're running on a straight track for 10 seconds. It's from 0 to 10 seconds. A straight track, not a curved track. The graph below, which consists of line segments, shows the velocity in meters per second for runner A. All right, so this is runner A. should have given them a name. Too lazy. This is velocity. All right. So this is velocity. Velocity is increasing, so acceleration is increasing. Or it's not acceleration is increasing, that's wrong. Acceleration is positive. Right here, velocity is positive. Acceleration is 0 because it's not changing. Acceleration is the derivative of velocity. All right, runner B, his velocity, or her velocity, is given to you by an equation. So that's runner B. So one runner given to you by a function, one given to you by a picture. Let's see what it asks. Find the velocity of runner A and the velocity of runner B at time 2. Indicate the units of measure. What? Find the velocity of runner A at time 2. Okay, where is that going? Is that 6 at 5 point? We got to know for sure, right? All right, so it looks like from 0 to 3, it went up 10 over 3. So to know what that is exactly, I kind of need to know like an equation. Because I can't just say it's like 6-ish. Looks like a little more. 6-ish something. All right, so runner A, his velocity at 2 would be equal to, okay, well, what is the function there? What is that line? We can do this. Y is equal to mx, so 10 over 3 x plus c, so plus 0, because it crosses the origin. All right, so it's up. So I'm plug in 2, so it'd be 10 over 3 times 2, which is 20 over 3. And the calculator's allowed, so you can get like 6.666666, or just keep it as 20 over 3. But yeah, 6.6 repeating, that kind of looks like we were going to get that right, but we might have got it wrong. All right, so be careful with that. And I need to make the units of measure, indicate units of measure. So velocity would be meters per second. It was given to us, meters per second. All right, runner B. Velocity at 2 is equal to, just plug it into the equation, 24 times 2, so 48, over 2 times 2, which is 4, plus 3 is 7. 48 over 7, if I wanted to reduce it, would be like 6.8571, but just leave it. And I would just say meters per second. All right, that one kind of seemed a little too easy. I guess that's all it was. The runner A was kind of hard, for me at least. All right, find the acceleration of runner A and the acceleration of runner B at times 2, and to indicate the units of measure. All right, so we have to understand that, or remember, that acceleration is the derivative of velocity, and the derivative is the slope at a moment. So for runner A, the slope there we found was 2 or 10 over 3. And the units would be meters per second, or if you're a physics person, you say meters per second squared. That's also fine. Okay, runner B, I have to find the derivative of this. So I kind of ran out of room on mine. Runner B, it's calculator active. So if I've defined that already in my calculator, I mean, I could do, what's it called, the quotient rule? Derivative of the top times the bottom like it is, minus top times the derivative of the bottom, all over the bottom squared. Or if I define V in my calculator into Desmos, say this is V of t, write that, and then V prime of 2, and you plug that into the calculator, and it would tell you 1.4693 something. And then that would be meters per second also. All right, so next one, find the total distance, not just like net change or displacement, total distance. So the idea behind like net change If I'm going to the right, that's a positive velocity. If I start going back left, it's a negative velocity. And if velocity was 3 for a second, and then it was -2 for a second, then it traveled to the right 2 meters, left 2 meters, right 3 meters, left 2 meters. Now it's back 1 meter away from where it started. So if I integrated this idea, it would give me 1. But if I integrated the absolute value to find the total distance, I don't care that that's a -2. I find that the total distance traveled was 5. So displacement, I'm gonna write both formulas. This is not part, like this is just extra for your learning. That's displacement. This is total distance. You have to memorize that. So the total distance takes away the negativeness, and it just adds up all positives. And if it wants displacement or how it moved, how it changed, then you would pick that other one. But all right, so total distance for runner A. I'm going to label it runner A. Total distance. Oh, okay, wait. I don't have an equation for runner A. I just want to integrate from 0 to 10 of runner A's V. So I might write V sub A of T. And if I don't have a function, I got to remember this is just the area bounded by the curve. So if I add up the area or find the area bounded by the curve and add that area, then there will be the total distance traveled for this runner A. And this going into a straight path, it's just running one direction. So 3 times 10 is 30. Divide that by 2, that would be 15. And this would be 3 to 10 is 7. 7 times 10 is 70. Cut that in half. I think that's 35, right? Oh, but I don't cut it in half, dummy. 7 times 10 is 70. So add up 15 and 70, get 85 for runner A. 85 meters. All right, runner B. I'm going to integrate from 0 to 10 the absolute value of its function. And if I've already defined it in Desmos, so it's real helpful, if it's calculator active, to go ahead and define this equation. And if I want to go back and find more things with it, just type in absolute value with the integral from 0 to 10. And Desmos should spit out the number 83.3361. And if I integrate a rate, it gives me a total amount, so total distance traveled. All right, that's it for this video. I'll make another video for the other FRQs. So thanks for watching. Keep working hard, and I hope it pays off on your test. Bye.